This video is to help you with your notes on the triangle sum theorem, section 4.2. The first big idea we have here is the triangle sum theorem. We're going to try to figure this out on our own before I just go out and tell you. So with your team, you can use a straight edge and draw 3 triangles, one acute, one right, and one obtuse. There's my acute one. For a right one, I'm going to use the right angle up here on my ruler. Extend that out a little bit. And I'm going to draw an obtuse one down here. So here's my acute triangle. Here's my right. And here's my obtuse triangle. With a protractor, I'm going to want you to measure all of the angles. Let's call this angle A. Let's call this angle B. Let's call this angle C. We'll call this angle D, E, and F. And let's call this angle X, angle Y, and angle Z. I'm going to let you do that on your own here. With the protractor, you're going to measure each angle. Now you can have one person do one triangle, another person do another one, another person do a third one. But then you're going to write down what you notice about the sum of the angles for the acute triangle. So how many degrees this is, plus this, add them all up. Add up angle A, B, and C, and tell me what you get. Measure of angle A plus the measure of angle B plus the measure of angle C equals what? Do the same thing for the right triangle. And for the obtuse triangle. I'm going to pause and let you do that for a moment. All right. I'm assuming you pause the video and you add up all those measures, and you should get something close to, each of one of these should be close to maybe like 180 degrees, something close to that. Maybe, possibly. What I want you to do now is go to my website under the Geometry tab and Help Videos page. You'll find a Chapter 4 video, and it's called Triangle Sum Theorem Demonstration. Watch that video, and we're going to see that indeed the triangle should have 180 degrees. The sum of the 3 angles should add up to 180 degrees. Go watch that video. Now we're going to actually prove it. So the triangle sum theorem right here is the big idea. Here's the, we're going to do a proof of this. So we're going to start with triangle ABC. And we're going to draw a line parallel to it, and we're going to call it AD. So we're going to draw this line right here. And we're going to label our new angles 4 and 5. Now we've got angles 1, 2, and 3 down here as well. And 1's the same as C, 2's the same as B, and 3's the same as A. Since 3, 4, and 5 make up this line right here, we know they have to add up to 180 degrees. Take a moment, pause the video here, try to fill in these steps right here, and see if you can figure out the rest of the proof on your own here. Alright, by now you should have paused the video and try to fill it in on your own, and we'll go through it together here. If you didn't pause the video and try to fill it on your own, shame on you, you're a horrible person. Not really. Alright, because AD is parallel to BC, angle 1 and angle 4 are alternate interior angles. And that means they are congruent. Angle 1 is congruent to angle 4. These are alternate interior angles. Since the lines are parallel, angle 2 and angle 5 are also alternate interior, and that means angle 2 is congruent to angle 5. Now, if they're congruent, that means that they're also equal. So measure of angle 1 equals measure of angle 4. Angle 2 is equal to angle 5. And that's the definition of congruence right there. If two angles are congruent, then the measures have to be equal. Now, we know angle C is the same as angle 1, and angle 1 is congruent to angle 4. B is the same as angle 2, which is equal to angle 5. And angle A in the triangle is the same as angle 3. So up here we had measure of angle 3 plus measure of angle 4 plus the measure of angle 5 equals 180. Instead of angle 4, I can put in angle C. Instead of angle 5, I can put in angle B. Instead of angle A, instead of angle 3, I can put in angle A. So that means measure of angle A plus the measure of angle B plus the measure of angle C equals 180. Now, what property is that called? It means we can substitute or plug them in to get measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. QED, we have proved it. So if you didn't believe my other video demonstration of it, and just looking at a bunch of different triangles, we've officially proven that there's 180 degrees in any triangle. All right, let's do some problems together here. First, we're going to find the measure of each angle here. Well, I know by the triangle sum theorem, I know measure of angle M plus the measure of angle A plus the measure of angle T equals 180 degrees. Now, since M is 82, I'm going to substitute that in. Since A is 27, I'm going to substitute that in. I'm going to add these two together and get 109 degrees. If I subtract 109 from both sides, I'm going to get the measure of angle T is 71 degrees. Now, so this is 71 degrees right here. All three of these angles are acute. They're less than 90. So triangle MAT is acute. Let's do this one down here. Same thing. All three of these angles, we don't know what they are. We don't know what the x is, but they have to add up to 180. So 8x minus 1 plus 3x plus 4 plus 3x plus 9 equals 180. All right, I'm going to combine like terms here. I'm going to get 14 x's. Negative 1 plus 4 is 3. 3 plus 9 is 12. And subtract 12 from both sides. Get 178. Divide both sides by 14. Oh, not 178. My apologies. 168. And that's going to be 12. X is equal to 12. But it doesn't say find x. It says classify the triangle. It says find the measure of each angle. We're going to classify it. So up here we're going to do 8 times 12 minus 1. So that's going to be 96 minus 1. That's 95 degrees. 3 times 12 plus 4 is going to be 40 degrees. And 3 times 12 plus 9 is going to be, that's 36 plus 9 is 45 degrees. So we've got 45 degrees, 40 degrees, and 95, but that's obtuse. So this triangle is obtuse. And that's your notes over the triangle sum theorem.